Hello. All right, so let's review for this third test here. All right, so let's take a look at number one. Now, number one says this given expression is equivalent to which of the following? Now, we know this is just a division bar here. So why don't we take this numerator and divide it by the denominator? Okay, so I rewrote this over here. Now, if you notice, see how the exponents go from x to the fourth down to x to the third, down to x to the first, right? We skipped over x squared. When you write this expression under the division bar, make sure you take into account that x squared term. We could rewrite that. If we have no x squared, can't we write that as 0x squared? Okay, so we need this placeholder here for us. All right, so let's get started. So the first thing we do is we look at this first term, which is just an x, and we look at this first term, which says 5x to the fourth. And you want to say in your head, well, what would I multiply x by to give me 5x to the fourth? Well, I would multiply it by 5x to the third, right? So what we're going to do is we're going to put a 5x to the third on the top, right here. Okay, so now we just kind of distribute this 5x cubed to both terms outside the division bar. So 5x cubed times x would be 5x to the fourth. Sorry, those fours are kind of ugly. And then 5x cubed times 7 would be 35x cubed. So plus, because it's positive, 35x cubed. Okay, now, we know what we do is we subtract this expression from this expression right here, from these two terms. So to show you're subtracting, what you do when you subtract is you just change your sign. So let's do it. So let's change this to a subtraction sign and circle it to show we're using it. And let's change this addition sign here to a subtraction sign and circle it to show we're using it. All right. So basically, the first two terms should always cancel off, right? If they don't, it means we made a mistake. So a positive and a negative of, the same thing, cancel off. And then here, positive 33x cubed minus 35x cubed would be negative 2x cubed. All right, so since we have two terms out here and only one term here, what we need to do is we need to bring down the next term, all right? Because you always want to have the same number of terms here that we're working with as we have out here. All right, so now we look at this again. We look at the first term here and the first term here, and we say, what do we multiply x by to give us negative 2x cubed? Well, we're going to multiply it by a negative 2x squared. So let's put that on the top, negative 2x squared. All right, and then we just repeat the same process. So negative 2x squared times x would be negative 2x cubed. And then negative 2x squared times 7 would be negative 14x squared. All right, so again, we want to subtract these two terms from these two terms. So to show that we're subtracting, what we do is we change our sign. So I'm going to change this subtraction sign to an addition, and I'm going to circle it to show that's what I'm using. And then I'm going to change this subtraction sign to an addition, and I'm going to circle it to show that's what I'm using. All right, so again, the first two terms cancel off, which we always want to happen, right? All right, so those cancel. And then here, if I combine 0x squared plus 14x squared, that gives me positive 14x squared. Okay, and again, we're going to bring down the next term. Okay, and the reason we bring that down is because if we have two terms out here, we want to have two terms down here. That when we combine our like terms, we'll combine two terms with two terms. All right, so start the process again. What can I multiply this first term by to give me this first term? So I would multiply x by 14x in order to give me 14x squared. So I'm going to put the 14x on top. And then let's distribute. 14x times x is 14x squared. And then 14x times 7 would be, 98. So positive 98x. All right, so again, we're going to subtract. So we're going to change our signs. So change this to subtraction and circle it. Change this to subtraction and circle it. Circle the sign you're using, right? So you know which one you're using. All right, the first two terms cancel, so I'm just going to put a little slash through that. And then when I combine positive 96x and then minus 98x, it's going to leave me with negative 2x. And let's bring down the next term. And one last time, we're going to say, what do I multiply x by to give me negative 2x? Well, negative 2. And then let's distribute. Negative 2 times x is negative 2x. And then negative 2 times 7 is negative 14. All right, so we're going to subtract again, so let's change our sign. So change to addition and circle, change to addition and circle. All right, so the first two terms again cancel. And then when I combine negative 16 plus 14, that gives me negative 2. Now, since I have nothing left to bring down, this is called my remainder. Okay, and what we do is we take our remainder and we put it over what we were dividing by. Now, if your remainder is a negative, you would put minus, and then let's put a fraction bar. We put our remainder on the top of the fraction bar. Now, since I already put this negative here, the only thing that's going on top of the fraction bar is going to be a 2. And then we're going to put the x plus 7, whatever you have out here, on the bottom of that division bar. Okay, so we're left with 2 parts, actually really minus 2 parts, out of the x plus 7 we were dividing by. All right, so if we look, that matches up with choice 1. So choice 1 is our answer. Okay, one other thing I want to point out. You know me, I'm a big fan of checking to make sure we got this right. So what I did was I plugged in the original expression into my calculator, right, just using x's. X is stored as whatever it is in my calculator, okay? And when I plug this in, it gave me some value. Okay, that value is what this expression is equal to with whatever x is currently stored as in my calculator. Now, also what I did was I took the answer choice that I got and I plugged that in my calculator and hit enter. And if you look, this value matches up with this value. So what it means is these two expressions are equivalent. If you had plugged any of these answer choices into your calculator and hit enter, it wouldn't have given you the same value because they're not equivalent. Okay, number 2 is pretty much the same thing as number 1. It's the same thing. All they're asking you to do, they give you an expression and they give you another expression and it says express a of x divided by b of x. So they're just saying take this and divide it by that. And when they say to express it in this form, all they're telling you is that you're going to be left with a quotient plus some remainder over what you were dividing by. So let me just show you what I mean. I mean, technically, that's exactly what we did in number 1, right? Weren't we left with, see how they say this here? Weren't we left with some quotient, right? The answer you get when you divide. And then plus, in this case it was minus, the remainder, right, over what we were dividing by. Okay, so number 2 is the same exact thing. All right, so we're just doing long division. Okay, now this one, see, same thing as what happened in number 1. See how the exponents go from x to the 4th down to x to the 3rd, and then it jumps to x to the 1st. We were missing that x squared term. You want to put a placeholder here, okay? Since we have no x squared term, we put plus 0x squared, and that way we take into account every single term. All right, so let's do it. So we look at the first term here and the first term here, and we say, well, what do I need to multiply this x by to give me 2x to the 4th? Well, I need to multiply it by 2x cubed. So let's put that on top. Oop, that's supposed to be a 3. And then we're going to distribute. 2x cubed times x would be 2x to the 4th. And then 2x cubed times 1 is 2x cubed. Okay, now we want to subtract this expression from this binomial expression here. All right, so we know when we subtract, right, we're going to change the signs. I've got a lot of colors going on here, and circle it to show we're using it. And I'm going to change this addition to a subtraction, and I'm going to circle it to show that's what I'm using. Okay, that right there, that kind of was a little messy. If you prefer, right, you can just put the subtraction sign over the addition and circle it. That way you can really see what you're using. Okay? All right, so now 2x to the 4th minus 2x to the 4th. That's going to cancel out, and that should always happen with the first terms. And then here, negative 8x cubed minus 2x cubed is negative 10x cubed. Remember, you're always using the sign you circled. So negative 8 minus 2 is negative 10. So that's going to leave us with negative 10x cubed. All right, and then we're going to bring down the next term. Okay, you always want to bring down however many terms you have to, so that you have the same number of terms down here as you do outside of the division bar. All right, so let's repeat the process. What do I multiply x by to give me negative 10x cubed? Well, we multiply it by negative 10x squared. So let's put that on the top here. All right, so distribute negative 10x squared times x would be negative 10x cubed. And then negative 10x squared times 1 is negative 10x squared. All right, so now we want to subtract this binomial expression from the one above it. So to show that we're subtracting, we change our signs. Okay, so I'm going to change the subtraction to an addition and circle it to show I'm using it. And I'm going to change this subtraction to an addition and circle it to show that's what I'm using. Okay, so our first two terms cancel, which we know should always happen. And then here, when I combine 0x squared plus 10x squared, that gives me 10x squared. And let's bring down the next term. Oop. Okay, so plus 5x. Okay, so here we go again. What do I multiply x by to give me 10x squared? Well, 10x, so let's put that on the top. All right, so then 10x times x is 10x squared. And then 10x times 1 is 10x. All right, so let's subtract. So we're going to change our sign. So change this to subtraction and circle it. Change this to subtraction and circle it. All right, so the 10x squared and the negative 10x squared cancel off. And then 5x minus 10x would be negative 5x. Right, 5 minus 10 is negative 5. And let's bring down that last term, which lets us, know this is the last time we're going to have to repeat this process. Okay, so what do we multiply x by to give us negative 5x? Well, negative 5. Oop. All right, so negative 5 times x is negative 5x. And then negative 5 times 1 is negative 5. So now, when we change our sign so that we could subtract, this subtraction becomes an addition, and this subtraction becomes an addition. So again, the first two terms cancel off, and then negative 4 plus 5 equals positive 1. So that right there is our remainder. Now, we don't stop here. Remember, what we do is we add on. So since this is a positive one, right, we're going to add on instead of subtract off the remainder. So we're going to have plus, and then 1 over what we were dividing by right here, which is x plus 1. Okay, I'm going to rewrite this because this is a little messy. Okay, so this is my final answer. And let me just explain why that's in the form of this right here. Okay, so q of x just means the quotient of x. The quotient is the answer you get when you divide. So this is our quotient. Now, they wanted us to also add on to that the remainder, right? R of x stands for the remainder, which is 1. So we put that there, over b of x, right? Wasn't b of x what we were dividing by, which is x plus 1? Okay, so all they really wanted you to do was long division. They were telling you, you will have a remainder. All right, so if we take a look at number 3, it says to determine the remainder when this expression is divided by x plus 2. Now, I'm not going to go through it this way. I showed my work, okay? I took my expression and I divided it by x plus 2. And I did the work the same way I did in numbers 1 and 2. And you could see I wound up with a remainder of negative 45. Now, the reason why I didn't really want to do it this way is because we learned a shortcut, right? We know that if we divide by x plus 2, right, whatever remainder we have is the same value that we're going to get if we take x equals negative 2, right, the opposite sign, and substitute it in for the x values. So this is what I mean. Let me show you. Okay, so what I did was I took this expression, and wherever I saw an x, I just substituted it with a negative 2. Okay, and all you're doing is, if this says x plus 2, the 0 that would correspond with a factor of x plus 2 would be x equals negative 2. Remember, you change the sign? All right, and then all you have to do is just evaluate this. Just figure out what this entire expression is equal to. All right, and when you do, you will get negative 45. Okay, so same thing as our remainder over here, except this is a lot faster. Plug in a number and evaluate it rather than doing the whole entire long division problem. Number 4 asks us to determine all the factors of this expression if one of the factors is 2x minus 1. All right, well, we know that if this is a factor of this expression, it divides evenly into it. All right, so let's do long division, right? And because this is a factor of this expression, we should wind up with no remainder because it's dividing evenly into it. Okay, so here we go. So for long division, we want to look at this first term on the outside and the first term under the division bar and say, well, what can I multiply 2x by to give me 6x cubed? Well, I'm going to multiply it by 3x squared. So I'm going to put that on the top here. And then just distribute the 3x squared to this binomial. So 3x squared times 2x would be 6x cubed. So let's bring that down here. And then 3x squared times negative 1 is negative 3x squared. All right, then we're going to change our sign and circle it to show we're changing it, and change our sign and circle it to show we're changing it. Okay, when you subtract, the signs change. So the first two terms cancel out, and then when we combine these two terms, negative 29x squared plus 3x squared will be negative 26x squared. And let's bring down the next term. All right, so now what do we multiply 2x by to give us negative 26x squared? So negative 13x. So that's what I'm going to put on the top here. Okay, and then let's distribute the negative 13x to both terms right here. All right, so negative 13x times 2x would be negative 26x squared. And then negative 13x times negative 1 would be positive 13x. Okay, so let's subtract. So to show we're subtracting, we change our sign and circle. Change our sign and circle. Okay, so if you don't see the circles there, it means you've got to change your sign. So remember to change them in circle. All right, first two terms cancel off. And when we combine these next two terms, negative 47x minus 13x is negative 60x. And then finally, let's bring down that last term. And remember, we don't want to have a remainder. We shouldn't have a remainder. If we have a remainder, it means we made a mistake. Because if 2x minus 1 is a factor of this expression, it should divide evenly into it. There should not be a remainder. All right, so we're going to say, well, what do I multiply 2x by to give me negative 60x? So negative 30. All right, now let's distribute. Negative 30 times 2x would be negative 60x. And then negative 30 times negative 1 would be positive 30. And we got it to work because look at this. When we subtract, when we change our signs and circle, look at that. Everything cancels. So we end up with no remainder. Now we're not done because it said determine all the factors, okay? So we know that 2x minus 1 is one of the factor. But aren't factors what multiplies together to give us this original expression? So if we did this original expression divided by 2x minus 1, and this was the quotient, this was our answer, wouldn't that mean if I multiplied this trinomial times this binomial, wouldn't it give me this original polynomial that we had? So basically, this is one factor, and this is another factor. So I'm going to write those out. All right, so 2x minus 1 is one of our factors. And then 3x squared minus 13x minus 30 is another factor. Now, here's the deal. If anything can factor further, you want to factor further. So this doesn't factor further, but if I look here, this is a trinomial. I'm going to see if I can factor this further. Okay, so let me just give myself a little more room. All right, so I don't want to forget about this 2x minus 1 because when it said to determine all the factors, this is still a factor. We have to, have that in our answer. We want to keep bringing this down. If it said determine all the remaining factors, then we wouldn't have to include that. Okay, so now let's see. If we look at this trinomial, we want to say, can I factor out a greatest common factor? Well, we can't. And since there's a number other than 1 in front of the x squared, in front of our first term, that tells us we're going to have to do the rainbow, which, leads us into factor by grouping. All right, now when we do that, what we do is we bring down the first term. I'm going to leave a big space, and let's bring down that last term. All right, now when I say the rainbow, what we do is we multiply these two numbers together, which gives me negative 90. So I have to come up with two numbers that multiply to negative 90, and at the same time add to negative 13. All right, well, if they multiply to negative 90, they're going to have different signs. So one of them is going to be negative, and the other one's going to be positive. And you may have to do a little trial and error to see what works. Remember, we learned to, oh, my phone's ringing. Okay, I'm back. I'm sorry. I had to hit pause to answer the phone. Let me see where we were. Oh, yes, we were coming up with two numbers that multiply to negative 90 and add to negative 13. And we were saying they have different signs. So, all right, so if you want, you could use your calculator trick, or if you want to, negative 90 divided by 2, negative 90 divided by 3, until you finally come up with it. But you should wind up getting, let's see, negative 18 and positive 5. Now remember, if this middle term has an x on it, we need to attach x's to these. So we have minus 18x and then plus 5x. Okay, so let's keep factoring. Now we know this polynomial right here, we're going to have to, now that we have 4 terms, we're going to group. All right, now let me bring down the 2x minus 1, because we don't want to forget about that first factor. And then out of these first two terms, I could pull out a 3x, which leaves me with x minus 6. All right, I don't know what's going on with that parenthesis. Okay, out of the next two terms, we could factor out a positive 5, which also leaves us with x minus 6. So awesome. That's how we know we're on the right track, when these match up. Okay, so, and keep in mind, I double closed the parentheses. I closed this one, closed up this one. And then this last parenthesis closed up this one all the way over here. All right, so now I'm going to take my 2x minus 1, and I'm going to bring it down. And I'm going to take the 3x and the plus 5. Okay, don't forget to write that plus sign there. Some of you guys are still just putting a 5. Make sure you write plus 5. And we're going to group the 3x plus 5 together as one of our factors. And then our final factor is this common binomial of x minus 6. So this right here, these are the 3 factors of this original expression, okay? If you were to multiply all of this out, you would wind up with this expression right here. All right, and a super easy way to check is if this expression factors to give you this expression, right, these 3 factors, then it means they should be equivalent to each other. They should be equal to each other. So what I did was I plugged the original polynomial in my calculator, and then I plugged my final answer in the calculator as well. You can't see the 6 because it didn't fit on the screen, but the 6 is really there. And you'll notice that these values match up. So it means that these two expressions are equivalent to each other. Okay, this is just a check technique. You could check a lot of things in your calculator, and when you're taking a test, that's super important to do. All right, number 5. This, I think, is probably the longest one on the review sheet. It says, given that h of x equals this expression, okay, and keep in mind there's a b. We don't actually know what this expression is. And h of negative 8 equals 0, algebraically determine all the zeros. Okay, so I'm going to underline this. This is actually what our final answer is going to be. We have to figure out what are the zeros. What, values of x would make this equation be equal to 0, right? That's what zeros are. Now, let's think about this. We don't even know. This is a b. So the first thing I'm thinking is, let's try to find out what this b is equivalent to. Now, when they say that h of negative 8 equals 0, see, this is h of x. If you look, see this x? They're replacing it with a negative 8. So what that means is, if we replace all these x's with negative 8's, this expression will be equal to 0. So again, if we replace, this is what I did, I replaced all the x's with negative 8s, right? If we replace the x's with negative 8s, our expression equals 0. So let me bring down equals 0. Okay, so now we can solve this for b. All right, so the first thing you're going to do is you're going to figure out what this is all equal to. Okay, so negative 8 to the third is negative 512. And negative 512 times 6 it's a big number. Let's see, negative 3,072. Okay, now this next term, right? This is b times negative 8 squared. So negative 8 squared is 64. So I'm going to write this as 64b. So plus 64b. All right, and then negative 23 times negative 8 would be positive 184. So plus 184. And then I'm just going to bring down the minus 120 and the equals 0. All right, so let's combine our like terms. So if we combine these numbers, right, this number, I can't do this because it has a b on it, right? That's a b, not a 6. So if I combine together this number, and this number, it gives me negative 3,008. So we have negative 3,008. And I'm going to bring down the plus 64b. Actually, could have written that first, right? And then I'll bring down the equals 0. All right, so to solve this, we want to get the b by itself. So let's first add 3,008 to both sides of the equation. All right, so it leaves me with 64b equals 3,008. And then just divide by 64. All right, so it leaves me with b equals 47. All right, so that's what b is equal to. So now that we know what b is equal to, we actually know this expression. Okay, so I basically just rewrote this expression, but in place of b, I put the 47. So this is what h of x is equal to. All right, so now let's go back to the question. It says, algebraically determine all the zeros of h of x. Now this is important algebraically, because I mean, if we want to determine the zeros, we could go to y equals in our calculator and plug this in and just look at where the graph intersects the x-axis, okay? We could find all the points where the graph intersects the x-axis, but they want us to do it algebraically, not graphically. All right, so let's think about this. Okay, so my first thought would be to maybe take this and set this equal to 0 and factor, right? Because if you factor, then you could always make a t-chart and solve and find your zeros. Now, I'm looking ahead here. This is not going to factor nicely for us by grouping, okay? Here, I'm going to do this in a different color. I'm going to erase it. If you basically tried to factor this and, set it equal to 0 in order to solve, out of the first two terms, we could factor out an x squared, which leaves us with 6x plus 47. And out of the next two terms, I guess what you would factor out a negative 1, right? Which does not leave you with 6x plus 47. Leaves you with 23x plus 120. Okay, so, I mean, these do not match. So we can't factor. If we could factor this, it would have been awesome. We could have just made, our factors, a t-chart, and solved. Okay, but that's not going to work for us. So let's get rid of that. All right, well, let's take a look at what we're given. This not only helped us to find the b, right? But this is important. Think about it. If h of negative 8 equals 0, what they're telling us is that when you substitute in the x's with negative 8, the expression is equal to 0. So basically, x equals negative 8 is one of the zeros of our function. So if we know that x equals negative 8 is a 0, right, of our function, doesn't that mean that x plus 8 is a factor? Okay, and that's totally going to help us. Because if x plus 8 is a factor of our expression here, right, of our function, then can't I just divide this by x plus 8 to find the other factors, right? And then once we have it in factored form, we can finally determine the zeros. So again, this is a super long question. Okay, so I'm just going to say it one more time. Since x equals negative 8 is a 0, we know that x plus 8 is a factor. And if x plus 8 is a factor, it means it's going to divide evenly into this expression. So what I did was I'm taking this expression and I'm dividing it by x plus 8. All right, now we've already done long division a few times already within this review sheet, so this should be okay with you guys. If you know how to do this part, you can just fast forward, just skip right through it. Okay, so to do the long division, let's look at the first term on the outside of the division bar and the first term underneath the division bar. And you want to say, what do I multiply x by to give me 6x cubed? Well, I'm going to multiply it by 6x squared, so let's put that up there. And remember, we should not be getting a remainder in the end because if this is a factor, it's going to divide evenly into it. Okay, anyway, let's distribute the 6x squared to both terms down here. So 6x squared times x is 6x cubed. And then 6x squared times 8 is 48x squared. Okay, so let's subtract. So we're going to change our signs and circle it. Change our sign and circle it. All right, so the first two terms cancel off. And then 47x squared minus 48x squared is negative 1x squared. I'm just going to write negative x squared. And let's bring down the minus 23x. All right, so repeat the process. What do I multiply x by to give me negative x squared? Well, negative x. So then negative x times x is negative x squared. And negative x times 8 is negative 8x. And again, we want to subtract, so whenever we subtract, we change our signs to show we're subtracting. So let's change the sign and circle it. Change the sign and circle it. All right, so these first two terms cancel. And then negative 23x plus 8x would be negative 15x. And let's bring down that last term. So this should be the last time we're doing this. All right, so what do I multiply x by to give me negative 15x? Negative 15, so let's put that at the top. And when we distribute, right, as long as we have no remainder, it means we are on the right track. So negative 15 times x is negative 15x. And by the way, if we do wind up with a remainder, we'll go back and find our mistake, okay? And then negative 15 times 8 will be negative 120. All right, so when we subtract, we're going to change the signs and circle it, and you'll notice everything cancels. All right, perfect. So we got this so far. So since there's no remainder, the x plus 8 divides evenly into this expression. So if we were to take this expression right here and factor it, x plus 8 would be one of our factors, and this trinomial, 6x squared minus x minus 15, would be another factor. Okay, so what I'm going to do is underneath this, I'm going to write it in factored form. All right, so I'm going to go back to blue. So we have x plus 8 times 6x squared minus x minus 15. Okay, so that's what this factors to be. Now, we could see right here, we're going to have to factor this further. But I want to point something else out. It says to algebraically determine all the zeros. So we want to know, when does this equal 0? Okay, so the phone's interrupting, the bell's interrupting. All right, so let's basically set this equal to 0. All right, so let me give myself a little more room too. All right, so let me bring down the x plus 8. And we're going to factor what's in this parenthesis further. So this is similar to the last example, right? You want to say, can I factor out a greatest common factor? And we don't have one to factor out. So we're going to have to, since there's a number other than 1 in front of the first term, we're going to bring down our first term. We're going to leave a big space, and we're going to bring down the last term. It's supposed to be a minus sign. Sorry about that. And don't forget about the equal 0, right? We want to keep that in equation. And then we're going to do the rainbow. We need to come up with two numbers that multiply to, well, since 6 times negative 15 is negative 90, we need to come up with two numbers that multiply to negative 90, right? Multiply to the rainbow number, and add to -1, right? There's really a -1 in here. All right, I mean, actually, those aren't too bad, right? You're probably going to just use 9 and 10. Now, let's think about it. If they multiply to a negative, we're going to have different signs. So one of them is going to be positive, and the other one's going to be negative. And since it adds to a negative, your bigger number will be negative. So the 10 will be negative, and the 9 will be positive. So we have a positive 9 and a negative 10. And don't forget, since this term contains an x, we need to put x's on each of these. Okay, so now I'm going to bring down the x plus 8. And with these 4 terms, we're just going to do grouping, right? We group together the first 2 terms and group together the last 2 terms. All right, so to the first 2 terms, we could pull out a 3x, which leaves us with 2x plus 3. Just in case you forget how to do that, you just do 6 divided by 3 is 2. And we had x squared, right? We had 2 x's being multiplied together, and we took one of them out, so we still have 1 here. And then bring down your plus sign. 9 divided by 3 is 3, and we had an x, but we took it out, so we don't have to put an x here. Now, out of these 2 terms, we could either factor out a positive 5 or a negative 5. But here's the deal. You want to be left with a positive 2x and a positive 3 in parentheses. So if we want to be left with positives in the parentheses, it means we have to factor these negatives out. So I'm going to factor out a negative 5. And then negative 10x divided by negative 5 would be positive 2x. And negative 15 divided by negative 5 is positive 3. And then let's double close those parentheses and bring down the equals 0. Okay, don't forget to bring down the equals 0. We want to keep it an equation. All right, so now we got a lot going on here. Let's bring down the x plus 8. And then in my next parenthesis, I'm going to group together this 3x with the minus 5. Okay, and then finally, I'm going to take this common binomial of 2x plus 3 and rewrite that. And we're going to remember to bring down the equals 0, right? We want to keep it an equation. Now, if you remember, it did say, determine all, oops, sorry about that. It says to determine all the zeros, right? We want to figure out what values of x would make this equation right here equal to 0, all right? Or if we were to graph it, where does the graph intersect the x-axis? All right, so anyway, if we want to solve for the zeros, we have to keep solving, right? We have to figure out what x values make this equation true. All right, so we're going to just make a t-chart. Now, I know in this, first column, a lot of you guys just jump right to the answer. We get x equals negative 8. So that is one of our zeros. Now, we already knew that one, right? Wasn't that given to us? Oop, right up here, right? Didn't this tell us that, it didn't come right out and say x equals negative 8 is a 0, but it implied that x equals negative 8 is a 0. So that one we already know. All right, the other 2 are going to be new to us. Now, if you can look at this and just say the answer is positive 5 over 3, you can just jump right to the answer. If not, I think these ones are a little harder to do. I would just take that factor and set it equal to 0 and solve. Okay, so we can add 5 to both sides of the equation, which leaves us with 3x equals 5. And then just divide by 3. So it leaves us with x equals 5/3. Now, I just want to point something out. If you plug in your calculator 5 divided by 3, it'll give you 1.6 repeating. Okay, do not take it upon yourself to round that and write like 1.67 or 1.6 bar, right? We want to know the exact value, which is 5/3, right? If you substituted 5/3 back into this expression, it would be equal to 0. So please leave it as a fraction. All right, now here, let's do the same thing. So we're going to take 2x plus 3, set it equal to 0, and solve. All right, so we're going to subtract 3 from both sides of the equation, leaving us with 2x equals negative 3, and then divide by 2, which leaves us with x equals negative 3/2. Now this one if you plugged in your calculator negative 3 divided by 2, it would give you negative 1.5. Okay, see how that just stops? It doesn't keep repeating, doesn't keep going. It's negative 1.5. We call that a terminating decimal. If you want to write this as negative 1.5, that's fine, because that's exactly what you get. It's not like you have to round on your paper. All right, so anyway, these are our 3 zeros. Number 6 asks us to determine the value or values of x that make the following fraction undefined. Okay, well, if you remember, an undefined fraction is a fraction in which the denominator equals 0. Okay, so basically for these, the numerator, this, we're just going to ignore. We don't care about that, okay? We're going to set the denominator equal to 0 and then solve. We'll figure out what values of x make this denominator equal to 0. Okay, so let's do it. I took the denominator, set it equal to 0. Now, in order to solve this, we're just going to factor and then make a t-chart. So to factor this, the first thing we say is, can I factor out a greatest common factor? Which, yeah, we could totally do that. We could pull out an x, which leaves us with 4x squared minus x minus 3 equals 0. Okay, so we just pulled an x out of each of these terms. Okay, now we're going to look in the parentheses, and we have a trinomial, so we want to know, can we factor this further? If there was a 1 in front of here, we would do the add, multiply method, but because it's a number other than a 1, we're going to wind up doing the rainbow, right? All right, so in order to do that, the first thing we're going to do, well, let's bring this x down. And then after that, the first thing we're going to do is we're going to bring down the first term, we're going to leave a big space, and we're going to bring down the last term. All right, and then we have to come up with 2 numbers that multiply to our rainbow number. To get the rainbow number, we just multiply 4 times negative 3. So that gives us negative 12. Okay, so we have to come up with 2 numbers that multiply to negative 12. And there's really a negative 1 in front of this x, so they're going to add to negative 1. All right, so that would be negative 4 and positive 3. So I'm going to put negative 4. And then don't forget about the x, right? Because we have an x here, we have to include it here. And then positive 3, x. All right, so from this point, we're just going to group together the first 2 terms within the parentheses and group together the last 2 terms. Now, out of the first 2 terms, we could pull out, let's see, a 4x. All right, and that's going to leave us with x minus 1. All right, out of the next 2 terms, you have to decide, well, do I want to pull out a positive 3 or a negative 3? Well, if I want to also be left with an x minus 1 in parentheses, right? See how this goes positive, negative, and this also goes positive, negative. We want our signs to stay, so we're going to pull out, we don't want them to change, so we're going to pull out a positive. So let's pull out positive 3. And don't forget to put the plus sign in front of that 3. And when we do that, it'll leave us with x minus 1. All right, double close those parentheses, and don't forget to bring down the equal 0. So now we can kind of just organize our factors. This x comes right down, and then we take the terms that are in front of our common binomial, right, this 4x plus 3, and we group them together. And then we take this common binomial of the x minus 1, and that will be our final factor. All right, and please don't forget to bring down the equals 0, right? It's really important to keep it in an equation all throughout. We need this equals sign all throughout. All right, so now that we have our factors, now that it's all factored, let's make a t-chart and solve. All right, so we're going to just take each factor and set it equal to 0. Okay, I'm doing this one the long way. I know a lot of you guys can just look and say, all right, well, the answer is going to be x equals 1. All right, anyway, we're going to solve each of these equations. Now, this first one here is solved for us, right? X equals 0. There's nothing to solve. It's already there for us. So one of the values of x is 0. X equals 0. All right, in order to solve this next one, we're going to subtract 3. So that gives us 4x equals negative 3. And then when you divide by 4, we get x equals negative 3/4. If you prefer to write it as a decimal, in this case you can because it's a terminating decimal, right? It's a decimal that stops. You could write that as negative 0.75. And then here, when we add 1 to each side, we get x equals 1. All right, so those are our 3 solutions. You can leave it like that, or if you prefer, you can organize them in curly brackets. But when you do, please put them in order from least to greatest. Okay, so that's our answer. Okay, so number 7, it says to rewrite this fraction in simplest form. All right, well, we know if we want to simplify a fraction, we just factor the top, factor the bottom, and then see what cancels off. So I'm going to factor the top and the bottom like off to the side, and then I'll put its factors back into fraction form. All right, so let me start with this first one, the 2x cubed minus 4x squared minus 30x. Okay, so in order to factor that, first thing we could do is we could pull out the greatest common factor, which is 2x, and that's going to leave us with x squared minus 2x minus 15. All right, now since we have a trinomial, we want to say, can I factor this further? So because there's a 1 in front of the first term, all we have to do, this is the easier one, we just have to set up 2 sets of parentheses. And since this first term is an x squared, we're going to put an x in the first spot within each parenthesis. And then let's just come up with 2 numbers that add to -2 and multiply to -15. All right, so it would be -5 and +3. And then this 2x that's in front, let's remember to bring that down. Okay, so we factored the numerator of this fraction. So I'm going to put these factors in, let's do this, the numerator of this fraction. So we have 2x times x minus 5 times x plus 3. Okay, now let's factor the denominator of the fraction. All right, so if we have 4 terms, we're going to factor by grouping. Now, you first want to look and say, can I pull out a greatest common factor? But we can't, so we're going to jump right into grouping. So to the first 2 terms, we could pull out an x squared, which leaves us with x plus 8. Now to the next 2 terms, we're going to pull out a -25. The reason we're pulling out a -25 instead of a +25 is because we want to be left with positive x and positive 8 in parentheses. So here, I took the -25 and pulled it out so I could take this x and bring it down. Or you could just think about it like a negative divided by a negative is a positive. And then same thing here, -200 divided by -25 would be positive 8. So this is good. If our parentheses match up, oh, that's an 8, which they do, then we know we're on the right track. So I'm going to group together what's in front of the parentheses, the x squared minus 25. And then let's just rewrite the x plus 8 just once. All right, so now we want to look and say, well, can I factor further? I mean, this right here, you guys, I'm sure you guys recognize this. This is a difference of perfect squares, right? This is dots. So we know with dots, we set up 2 sets of parentheses. We put the square root of the first term in the first spot. We make 1 addition, 1 subtraction, and we put the square root of the second term in the second spot. All right, and then I'm going to bring down the x plus 8. Okay, so basically I took this denominator and factored it. So I'm going to put these factors in the denominator of our new fraction. All right, so we have x plus 5 times x minus 5 times x plus 8. All right, so let's see what cancels here. Actually, not much. And sometimes that happens. Sometimes a lot of things cancel, sometimes not much cancels. So here, the x minus 5 in the numerator cancels with the x minus 5 in the denominator. And then here, I mean, nothing that's on the top has the same factor as what's in the bottom. So looks like this is it. All right, so you can rewrite your answer one of 2 ways. You can either just leave it in factored form as 2x times x plus 3 over x plus 5 times x plus 8. So that's a totally acceptable answer. Or if you want to distribute the 2x into the parentheses, right, you'd have 2x squared plus 6x and then over, and you could double distribute this at the bottom. So x times x is x squared. I'm going to combine 2 steps in one here. X times 8 is 8x. Now when we combine that with 5 times x, which is 5x, 8x plus 5x gives us 13x. And then finally, 5 times 8 is 40. So this answer would be acceptable too. However you want to leave it, it's totally fine. In number 8, they want us to solve for x. Now, here we have fractional equations. So we know the first thing we have to do is we have to find a common denominator. Now I'm looking, and this one right here can be factored. So if you can factor a denominator, let's do that first because that'll help us out. All right, so since we have a 1 in front of our x squared, we just have to set up 2 sets of parentheses. And since we have an x squared, we're going to put an x in the first spot in each parenthesis. And then we just have to come up with 2 numbers that add to -1 and multiply to -12. So it would be what, -4, +3? Okay, so we have a -4 and a +3. Now, if we look at all of our denominators, right, this one has an x plus 3, and so does this one. This one has an x minus 4, whereas this one has a 4 minus x. So if you recall, you're allowed to switch the order of these two terms to make it say x minus 4, as long as you also change the sign in front of the fraction. Now, I'm going to do this in a different color so it stands out, okay? So I'm going to take this, let me try that again, and make it say x minus 4. But because, what I basically did was I took the negative x and made it positive, and I took the positive 4 and made it negative. Okay, so I'm changing the signs of what's happening here. So if I change the signs of what's happening here, I have to change the sign in front of that fraction. So I'm going to change the subtraction sign to an addition sign. Okay, so now here's our problem. Now I think you can all see at this point the common denominator is going to be x plus 3 times x minus 4. The common denominator, if it's included in any of the denominators, you need to include it in the common denominator. Okay, so what I did was I rewrote each of these fractions with the common denominator of x plus 3 times x minus 4. And I brought this down as an addition sign. Okay, so now what we want to do is we want to look at our original fractions, right? And we want to say, well, what is this missing? What is this denominator missing that the common denominator has? Well, it has the x plus 3, but it's missing the x minus 4. So I'm going to multiply the top and bottom of this, to do it in another color so it stands out, by x minus 4. Okay, so we can see in the numerator we have 2 times x minus 4. I'm going to put that right in here. Okay, 2 times x minus 4. Okay, now let's go to our next fraction. This just has the x minus 4. We want to say, well, what is this missing that the common denominator has? Well, it's missing the x plus 3. Okay, I didn't really leave myself much room here, so I guess I'm just going to put it after a fraction, x plus 3. Okay, and I'll just put it next to the x minus 4 here. Okay, so this is kind of a mess, but what's going on is I multiplied the top and bottom of this second fraction by x plus 3. Okay, so now the denominators of the second fraction match up, and I'm going to take what I have on top here, so 3 times x plus 3, and I'm going to put that on top of this fraction. Now, if we look at our last fraction, it already has the x plus 3 and the x minus 4 in the denominator, so we're not going to change this numerator. We're just going to take this numerator, and we're just going to bring it down. Okay, now once all the denominators are the same, we don't need them anymore, but you have to first make sure they're all the same, okay? Once they're the same, we could just cross them off, and what we're doing is we're solving this equation that we're left with in the numerators. Okay, so I'm going to distribute. 2 times x is 2x, and then 2 times -4 is -8. Okay, now we have a positive 3, right? This plus 3. So positive 3 times x would be positive 3x. And then positive 3 times 3 would be positive 9. And we can bring down the equals and the 2x minus 2. All right, so now we're just going to solve. So on the left-hand side of the equation, let's combine our like terms. 2x plus 3x is 5x. And -8 plus 9 would be positive 1. And then we'll just bring down the right-hand side of the equation. All right, so now, since we just have like x to the first power, right? There's no exponents or anything. You're just going to get all the x's to one side of the equation and the numbers to the other. So I'm first going to subtract 2x from both sides. So that'll leave me with 3x plus 1 equals negative 2. And then let's just subtract 1 from both sides. So we have 3x equals negative 3. And when we divide by 3, we get x equals negative 1. Now, we don't want to box this answer off right away. We want to check and make sure that it doesn't create an undefined fraction. All right, and this is what I mean. You want to look back at all your original denominators, okay? X plus 3, 4 minus x squared minus x minus 12. And you want to take this negative 1 and substitute it back in. So if you take negative 1 and add 3 to it, okay, that'll give you positive 2. You can have 2 in the denominator of the fraction. What we're looking for is we want to make sure when we plug this in that it doesn't create 0 in the denominator of any fraction. So if we take the negative 1 and plug it in here, 4 minus negative 1 is not 0. Okay, if we take the negative 1 and plug it in here, negative 1 squared minus negative 1 minus 12 also is not 0. So because it doesn't create a 0 anywhere, this will be our answer. But if it does create a 0 in the denominators of any of the fractions, we would have to cross off that answer, okay? That would be called an extraneous root. It does not work for us. Okay, so in addition to checking for extraneous roots, I always think it's a good idea to check your answer and make sure it actually, checks back out in the original equation. So this is what I did. I took a picture of what I did in the calculator. First, I told my calculator, every time I hit x, I want it to represent the number negative 1, okay? Because negative 1 was our answer. So what I did was I typed in negative 1, and then I hit the store button. The store button is the button right above the on button. It says stow with an arrow. And then I hit the X and I hit enter. So what I said was negative 1, store it as X in my calculator. Whenever I hit X, as long as I'm not on the graphing screen, it's going to represent the number negative 1. Okay, this is always a good way to check in your calculator. Then what I did was I plugged in the left-hand side of the equation exactly like I saw it in the original problem, plugged that in my calculator and hit enter. Then I plugged in the right-hand side of the equation in my calculator exactly like I saw it, and I hit enter. And see how these two values match up? What that means is when I substituted negative 1 in for x, right, this is the answer we got, the left side of the equation equals the right side of the equation. So our answer checks out. And you can do this for any equation. Okay, whenever you want to check an answer, your calculator, use the store button and plug in the left-hand side of the equation, plug in the right-hand side of the equation, and just make sure they match up. Okay, if we take a look at number 9, it's very similar to number 8 because we're given a fractional equation, right? We're given an equation that contains fractions. So when that happens, you want to try to find a common denominator. Now, this right here can be factored. So in order to find a common denominator, you first want to factor whatever denominators can be factored. All right, so here, since there's a 1 in front of our a squared, I'm going to set up 2 sets of parentheses, and I'll put an a and an a in the first spot, right, because a times a gives you a squared. And we just kind of want to come up with 2 numbers that multiply to 10 and add to negative 7. So negative 5, negative 2. All right, so I'm going to cross this off. We're going to use that now. Now, if we look at these denominators, this one contains the a minus 5, and this one contains the a minus 2, and there's nothing else in any of the denominators. So our common denominator is going to be a minus 5 times a minus 2. Okay, so now we want to look back at our original fractions, okay? So let's look at this first one. We say, what is this denominator missing that the common denominator has? Well, nothing. So that means we don't have to change our numerator either. Just take the numerator and just bring it right down. Okay, now let's look at this next fraction. You want to say, what is this missing that our common denominator has? Well, it has the a minus 5, but it doesn't have the a minus 2. So we need to put an a minus 2 there. All right, so if we're going to put an a minus 2 in the denominator, let's see if I could squeeze this, a minus 2. We're going to also put that up here in the numerator, a minus 2. So now on top we have 3 times a minus 2. I'm just going to leave it like that for right now. If you want to distribute, you can, but I'm going to leave it alone. And now the denominators match up, right? They have an a minus 5 and an a minus 2. All right, let's look at this last fraction. So here, this denominator has the a minus 2. But it's missing the a minus 5. So let's put the a minus 5 there. Now, if we want to put the a minus 5 in the denominator, we have to also put it in the numerator. Okay, that way it stays equivalent. So now our denominator has the a minus 2 and the a minus 5. Okay, it doesn't matter what order they're in. And on the top, we have a times a minus 5. So I'm going to bring that down. A times a minus 5. All right, now that all the denominators are the same, right, you have to first get them the same. And now that they are, we no longer need them, so we can just cross them off. So this is the equation. I'm going to bring it down exactly like I see it. This is the equation that we're solving. Okay, so let's bring down the 2 equals. Now let's distribute. 3 times a is 3a. And 3 times negative 2 is negative 6. Okay, now, this is a negative a. So you have to distribute this negative a to both terms. Okay, and if you had done it up here, right, you would have to think I have a negative a, because there's a minus sign in front of it. Let's distribute a negative a to both terms. All right, so negative a, let me get my pen again. Negative a times a would be negative a squared. And negative a times negative 5 would be positive 5a. All right, so let's just combine our like terms. All right, so we'll have 2 equals. Now on this side of the equation, I'm going to reorder these. I'm going to put my square term first. So I have negative a squared. Okay, and then I'll combine the 3a and the 5a. So 3a plus 5a is positive 8a. And I'll bring down the minus 6. Now, here's the deal. You want to get everything, because we have an exponent, right? We want to get everything to one side of the equation. Now, I don't personally like to have a negative leading coefficient, so I think it's easier to move everything over here. If you didn't think to do that, right, what you could do instead is you could subtract the 2. So we have 0 equals negative a squared plus 8a minus 8. And then you may look and say, wait a second, I don't want this negative in front. Let me now move everything over. Or if you want, think about it. If you just divide both sides of the equation by negative 1, okay, you could do it any of these ways is fine. Then you'll have 0 equals. And when you divide by negative 1, all these signs change. So we'll have positive a squared minus 8a plus 8. So positive a squared minus 8a and then plus 8. Okay, so from here, you want to say to yourself, all right, let me try to factor, make a t-chart, and solve. Now, here's the deal. If you try to factor this, right, because there's a 1, we would set up 2 sets of parentheses with an a and an a, but you'd have to find 2 numbers that multiply to positive 8 and add to negative 8. There are no 2 numbers that multiply to positive 8 and add to negative 8. So what we're going to do instead, if we have a quadratic and we can't factor it, we're going to use the quadratic formula. I put it up over here just so I would have a little bit of room. So, I mean, if you look down here, we could see, let's see, our a is the number in front of the a squared, which is 1. Our b is the number in front of the a, which is negative 8. And the c is the number all by itself at the end with no a attached to it, which is positive 8. All right, so let's plug this in. So we have x equals negative b. So negative 8 would be positive 8 plus and minus the square root of b squared. So you could either put negative 8 in parentheses and square it, or you could have just written 64, right? Okay, now minus, let's hope I could fit this, 4 times a, which is 1, times c, which is 8, and that whole thing is going to be over 2 times a, so 2 times 1. All right, so let's keep going. X equals, and don't forget the x equals. You have to keep it in equation the whole way through, right? If this was an equation, oops, sorry about that. If this is, see the equal sign, you have to have an equal sign in every step. So here's the equal sign, x equals. At this point, we're solving for x. All right, so from this point, let's see, we have x equals 8 plus and minus. Now we want to figure out what that's equal to under the radical. So negative 8 squared is 64. And then 4 times 8 is 32. So 64 minus 32 would be 32. And that whole thing is going to be over 2 times 1, which is 2. Okay, so now x equals 8 plus and minus. Now 32 is not a perfect square. So what we want to do, let me see if I can give myself a little room over here. I'm going to erase some of this. Okay, so let me go back to this. The radical 32, right, since it's not a perfect square, we can break this up into two separate radicals. So you have to figure out what's the biggest perfect square that divides evenly into 32. Now, I mean, I know 4 is a perfect square and it divides evenly into 32, so you could break this up into 4 and 8, but 4 isn't the biggest perfect square that divides evenly into 32. 16 is. 16 times 2 is 32. Okay, now let's think about this. The square root of 16 is 4, so I'm going to write that as 4, and then radical 2 we can't simplify, so I'm going to bring that down. So radical 32 simplifies to 4 radical 2. Okay, so I'm going to rewrite right here, right after the plus and minus, instead of radical 32, we're going to rewrite that as 4 radical 2. And that whole thing is over 2. Now, one thing I want to point out, I want to backtrack a step up here. If you notice, I didn't try to simplify the 8 and the 2 to make it 4 over 1, because technically there's a number in front of this radical right now, and you have to be able to simplify that number as well. Okay, there's really a 1 in front of here. And if you can't simplify the 1 with the 8 and the 2, you can't just do 2 out of the 3 numbers. You have to wait until you have a number here, here, and here, which we have now, right? We have an 8, a 4, and a 2. So now you can look and say, well, what's the biggest number that divides evenly into all of these? Well, 2 is. So 8 divided by 2 is 4. And then 4 divided by 2 is 2. And please, please, please do not try to divide the number under the radical by 2, okay? We can't do that. Just the numbers on the outside of the radical. So I'm going to leave it as radical 2. And that would be over, well, 2 divided by 2 is 1. You don't have to put anything over 1. So this would be our final answer. Number 10 asks us to write true or false next to each statement. Okay, so we're looking at this graph right here, right? And let's see, letter A, there is one relative maximum and one relative minimum. Well, that's true, right? This right here is a relative maximum, right? It's the highest point in a particular section of the graph. It's the top of a bump. And this right here is a relative minimum, right? It's the lowest point in a particular portion of the graph. Okay, so this is true. Letter B. There are two intervals where the function is decreasing. Okay, decreasing just means going down. So here the graph is increasing, here it's decreasing, and here it's increasing. So this is false. There's not two intervals where it's decreasing. It's just one interval where it's decreasing. So this is going to be false. All right, the degree of the polynomial is odd. Well, we know for an odd degree function, the arrows are pointing in different directions. So if this is pointing down and this is pointing up, they're pointing in different directions. So this is odd. Okay, so this is a true statement. For an even function, the arrows would be pointing in the same direction. They'd both be pointing up or they'd both be pointing down. All right, letter D. There is a positive, negative, ooh, that doesn't even make sense. Okay, I'm going to change this up here. I'm going to cross off the word negative and make that say leading, because then that would make sense, right? There is a positive leading coefficient. All right, well, we know if there's a positive leading coefficient, the only thing you have to look at to determine whether the leading coefficient is positive or negative is the arrow on the right, okay? You could ignore the whole rest of the graph. Just look at the arrow on the right. If it's pointing up, it has a positive leading coefficient, and if it's pointing down, it has a negative leading coefficient. So since it's pointing up, this is true. It does have a positive leading coefficient. All right, letter E. When f of x is divided by x minus 3, the remainder is 0. Okay, if we're dividing by x minus 3, right, what we want to do is we want to look at the 0 that corresponds with a factor of x minus 3. So if we have a factor of x minus 3, the 0 we're going to be looking at here is x equals positive 3, right? We change the sign. Now, this is a true statement if, when we go to x equals 3 on the graph, the y value is 0. Because remember, the y value of our function should be equal to the remainder, right? When we're dividing by whatever the factor is. Okay, so basically, if this is what we're dividing by, x minus 3, we're going to x equals positive 3 on the graph, and we want to say, is our y value 0? If so, this is a true statement. So when we go over to x equals 3, the y value is not 0. Look, the graph is like all the way up here. We can't even see it. It's all the way up here. So here, this would be a false statement because when x equals 3, the y value is not 0. So this is going to be false. Now, let me just point something out because I'm looking at this question a little more closely. If the question had said, when f of x is divided by x plus 3, so let's just say we were dividing by, I'm going to do this off to the side, x plus 3, okay? Wouldn't the 0 that corresponds with that be x equals negative 3? Now, if we went to x equals negative 3 on the graph, let's follow it over here. Look at that. The y value is 0. Okay, so the remainder would also be 0. So if they had rephrased this question as when f of x is divided by x plus 3, then it would have been a true statement. Okay, letter F. When f of x is divided by x. Okay, so x, I mean, you could think about x as x plus 0 or x minus 0, but basically 0 is the number that's associated with this, right? So like when we looked at, let's go back to letter 8. When we were dividing by x minus 3, wasn't the 0 that corresponded with it x equals positive 3? We just changed the sign. So here, if I took x, let's say I was dividing by, instead of just saying x, let's say x minus 0, because technically they're the same thing. Wouldn't the 0 that corresponds with that be x equals 0? Okay, that's where we're going to be looking on the graph, at x equals 0. Now, if the y value, when x equals 0, is negative 6, then we can say that this would be a true statement. We could say the remainder would be negative 6. Okay, we're going to look at the y value that corresponds with an x value of 0 and see if it's equal to negative 6. If so, that's what the remainder would be if we did long division. All right, so let's go to when x equals 0, and let's follow it to where the graph is and look at that. The y value is at negative 6. So letter F is a true statement. When x equals 0, y equals negative 6, which means the remainder would be negative 6. All right, so now we have end behavior, letter G. As x approaches negative infinity, so as we go to the left, the function approaches negative infinity, so the function goes down. So it says, as you go to the left, the function goes down. So let's look at our left arrow. Isn't this arrow on the left pointing down? All right, so that's true. Now here it says, as x approaches positive infinity, so as we go to the right, the function gets bigger. The function approaches positive infinity. So as we look at our right arrow, isn't that getting bigger and pointing up? So that statement, that end behavior statement, is a true statement. All right, and then the letter H. A possible factorization of f of x is x minus 3, x minus 1, x plus 2. Well, this one's going to be false because if we have a factor, like if we have, let's say, zeros at negative 3, negative 1, and positive 2, wouldn't the factors be x plus 3 and x plus 1 and x minus 2, right? Don't we change the signs? In letter H, right, we forgot to reverse those signs, so that would not be true. So I'm going to write false on that one. Okay, in number 11, they just want us to factor these three expressions. So let's start with the first one. All right, if we have two terms, right, we're basically looking for greatest common factor or dots. I know some of you guys like to reorder this. You know, you like to have the biggest exponent first and then, you know, have it go in descending order. When you have two terms, it's not necessary to do that. Can you do that? Yeah, definitely. That way, you know, you're consistent in every problem, but you don't have to do that. I'm just going to jump right into it. I'm not even going to rearrange them. So I'm going to look at these two terms and say, can I pull out a greatest common factor? Well, no, there's nothing that you could pull out of both of these two terms. So if we have a subtraction sign, as long as both of these two terms are perfect squares, we can do dots. And it winds up they are both perfect squares, right? So I'm going to set up two sets of parentheses. And the square root of 121 is 11. So let's put the square root of the first term in the first spot in each parenthesis. And then the square root of 9c to the 6 is 3c cubed, right? The square root of 9 is 3. And the square root of c to the 6 is c to the third. Because remember, that's supposed to be a 3. That came out really bad. Because remember, when you're multiplying two terms with the same base, we add the exponents, okay? So 3 times 3 is 9, and here c to the third times c to the third is c to the sixth because we add the exponents. And then if you recall, you just make one of them an addition sign and the other one a subtraction sign. Now, the one with the subtraction sign, you do want to look and say, is this dots again? Can we go further? But no, these aren't perfect squares. So this would be the final answer for letter A. Okay, so in letter B, let's see. So first, with the trinomial, you do want your terms always in standard form, right? So this is x squared, x to the first, and then x to the 0, technically. All right, so when we could look at it and say, well, can I pull out the greatest common factor? Well, no, there's nothing I could pull out of all three of those terms. So since there's a number other than 1 in front of the first term, that tells us that we are going to have to do the rainbow, right? Where we multiply together the first and last numbers here. So that gives us negative 36. Okay, now what we do is we bring down our first term. I'm going to leave a big space, and I'm going to bring down the last term. And we need to come up with two numbers that multiply to negative 36 and that add to positive 16. All right, so that's going to be positive 18 and negative 2. Now, since this middle term has an x on it, we need to attach x's to these two numbers. So we're going to have positive 18x and then negative 2x. Okay, so from here, we have 4 terms. We could do grouping. So we're going to group together the first 2 terms and then group together the last 2 terms. So out of the first 2 terms, we could pull out a 3x, and that's going to leave us with x plus 6 in parentheses. All right, out of the last 2 terms, we could either pull out a negative 2 or a positive 2. So if we want to be left with a positive x and a positive 6 in parentheses, we need to pull out that negative with the 2. So let's pull out a negative 2. And then that leaves us with positive x and positive 6. Okay, so that's good. So what we have in our parentheses matches. So we know we're on the right track. So what we can do is we could take what's in front of our parentheses, the 3x minus 2, and we can group them together as one of our factors. And then we can take this common binomial of x plus 6, and we can rewrite that as our other factor. And guys, remember with factoring, it's super easy to check because you can always double distribute out your answers, right? And see if it gives you that original expression. Okay, same thing here. You could double distribute and see if it gives you that original expression. All right, so with letter B, we're done because when you have 2 terms, the only thing we're looking for is dots, the difference of perfect squares, and neither one of these shows that, so these are our answers. Okay, now with letter C, a lot of you may be looking at this and be like, oh, we have 4 terms, let's just jump right into grouping. But remember, what's your first step in factoring? If you can, right, pull out a greatest common factor and look at these numbers. You can pull a 3 out of all 4 of those numbers. So let's start off by doing that. I'm going to pull out a 3, and that'll leave me with x cubed minus 4x squared plus 5x minus 20. Now, one thing I want to point out, please do not try to pull out an x with this 3, okay? You can only pull out a number because, look, this last term doesn't have an x. So if it doesn't have an x, you can't pull it out. Okay, so now once we pull out the greatest common factor, now we can look at our 4 terms and we could say, let's group the first 2 together and group the last 2 together. Now we could do grouping. All right, so out of these first 2 terms, we can pull out an x squared, which leaves us with x minus 4. Okay, out of the last 2 terms, you could pull out a positive 5. Now, please don't just write 5, right? If you're factoring out positive 5, you have to put the plus sign in front of that. And when you do, that also leaves you with x minus 4, which is good. Our parentheses match, right? That's what we want. All right, so I'm going to take this 3 and just bring it right down. Then I'm going to take the terms in front of our common parentheses, so the x squared plus 5, and I'll group those together. And then we'll take that common binomial of x minus 4, and that will be our final factor. Now, you do want to look and say, can I factor further? Do I have a difference? Well, this isn't a difference. This is a perfect squares. Well, although 4 is a perfect square, x is not. If this said x squared minus 4, we could factor further. But because it's just an x, it's not a perfect square, so this would be our answer. Okay, so let's take a look at number 12. It says solve for x. All right, well, I think what I'm going to do first to start is I'm going to distribute. So let me distribute the 6 into the parentheses. All right, so that leaves us with 9x squared equals, and then 6x plus, well, 6 times 2 is 12, so 6x plus 12. Now, whenever you have an exponent, right, you want to try to get everything to one side of the equation. I always like to have a positive leading coefficient, so I'm going to take these two terms and move them to the left. So when I do this, 6x becomes negative, and the 12 becomes negative. All right, so I'll have 9x squared minus 6x minus 12 equals 0. Okay, so now you could do one of two things to solve. This is called a quadratic, right? When your biggest exponent is a 2, right? It's called a quadratic. You can either try to factor and make a t-chart and solve, or you could do the quadratic formula. Now, if you take a minute and try to factor this, right, you're actually, I mean, you could try it out. You would first factor out a 3, and then you would have to try to do the rainbow from there. You would see that you actually do run into a dead end, and you're not able to factor it. So you wind up, you know, your option here is to do, the other option is to do the quadratic formula. All right, now, even though I'm going to do the quadratic formula, all of these numbers are divisible by 3. So to make my life easier, what I'm going to do is I'm going to divide both sides of the equation by 3. Because remember, whatever you divide one side of the equation by, you have to do to the other side of the equation. So that leaves me with 3x squared minus 2x minus 4. Okay, all I did was I just divided everything by 3. And then equals, well, 0 divided by 3 is just 0, so equals 0. Okay, so I'm going to go with the quadratic formula only because if you do try to factor this, you'll know that there are no two numbers that multiply to negative 12 and add to negative 2. So you're going to run into a dead end. All right, so with the quadratic formula, let me do this. Let me write out A equals 3, B equals negative 2, and C equals negative 4. Okay, so I'm going to do the quadratic formula over here. Give myself a little more room. So we write x equals, so negative b. Well, negative 2 would be positive 2 plus or minus the square root of b squared. So negative 2 in parentheses squared. If you don't want to deal with the parentheses, you could just put 4, right? Isn't negative 2 squared just 4? And then minus 4 times a, which is 3, times c, which is negative 4, and that whole entire thing, make sure your fraction bar extends underneath that whole entire numerator, is over 2 times a, so 2 times 3. All right, so we have x equals 2 plus the minus. Now we know we have to figure out what this is equal to under the radical. So if we take negative 2 and square it, that gives us 4, right? And then negative 4 times 3 is negative 12, and negative 12 times negative 4 is positive 48. So 4 plus, right, a negative times negative is positive, 4 plus 48 is 52. If you really, really struggle, with doing that by hand, you can always plug it in your calculator and just, double check your work. And then we're going to put that over 2 times 3, which is 6. Okay, so now we know we are not allowed to simplify these two numbers. Please don't try to make this 1 over 3. Okay, we first have to simplify our radical. So I'm just going to do that off to the side. All right, so radical 52. Now 52 is not a perfect square, so I want to come up with two numbers that multiply to 52 where one of them is a perfect square. And I want it to be the biggest perfect square possible. So the biggest perfect square that divides evenly into 52 is 4. And 52 divided by 4 is 13, so that's what I'm left with here. Now we know the square root of 4 is 2, so I'm going to rewrite this as 2 radical 13. Okay, so let's come back to our problem over here. So we have x equals 2 plus and minus. Now instead of radical 52, we already said that simplifies to 2 radical 13. And that whole thing is going to be over 6. All All right, now that we have a number in front of our radical, now we could look at all three of these numbers and say, well, what divides evenly into all of them? What's the biggest thing that divides evenly into 2, 2, and 6? Well, 2 is. So 2 divided by 2 is 1. Again, 2 divided by 2 is 1. And then bring down the radical 13. And 6 divided by 2 is 3. So that would be our final answer. Honestly, if you don't want to put this one here in front of the radical 13, you don't need it, because 1 radical 13 is the same thing as radical 13. But you do need this number 1 in front here, because 1 plus something is a lot different than not having a 1 here. If you don't have a 1 here, then it's implied at 0. So that one's necessary. Also, I know some of you guys like to separate it into 1 over 3. Here, let me do this. So some of you guys like to separate this into 1 over 3, and then plus and minus 1 radical 13 over 3, which I'm just going to write as radical 13 over 3. You can do that if you want as well, but you definitely do not have to, okay? So this is another option, but this is probably, I would say, what most of you have, okay? And that one's perfect. All right, and number 13, it says determine the zeros of f of x. All right, now it doesn't say whether to do it algebraically or graphically. I mean, you can always try it graphically first. All right, so what I did was in my calculator, I went to y equals, and under y1 I plugged in this function, and this is the graph. Now, I mean, honestly, I don't think graphically we're really gonna be able to solve this, because it looks like here, the function's coming up, it looks like it's going a little bit above the x-axis and then coming back down. And then over here, it looks like it's coming down a little bit below the x-axis and coming up, but I can't tell exactly where that's happening. And even still, 2x to the 5th, this is a 5th degree function. That means we could have up to 5 solutions. And honestly, I don't really see 5 solutions here. So I'm not gonna depend on my graph. Like, I really can't tell what's going on. So I'm gonna do this algebraically. So if we wanna solve this algebraically, we're just gonna take the function. And if you want to determine the zeros, all you do is just set it equal to 0. All right, so let's solve this. Now, the first thing I'm going to do is I'm going to say, can I factor out a greatest common factor? So yes, I can. I can factor out a 2x. Okay, so I'm going to solve this by factoring and making a t-chart. When I pull out a 2x, it leaves me with x to the 4th minus 17x squared, and then plus 72 equals 0. That's supposed to be a 0. There we go. Okay, so again, all I did was I took this expression, the left-hand side of the equation, and I factored out a 2x, which left me with x to the 4th minus 17x squared plus 72. Now, one thing I want to point out, I know a lot of you guys are going to realize this, but please do not try to use the quadratic formula for this. Just because there's 3 terms does not mean you can use the quadratic formula. The quadratic formula is used with a quadratic, which means your biggest exponent is x squared, not x to the 5th. So we do have to factor this. All right, so let's keep factoring. So I'm going to bring the 2x down. And then because I have a 1 in front of the first term of my trinomial, I don't have to do the rainbow. I wouldn't even bother with the rainbow. It takes a long time and it's more room for error. I would just have 2 sets of parentheses. And since this is an x to the 4th, I'm going to put an x squared in the first spot in each parenthesis. All right, and then I just have to come up with 2 numbers that add to negative 17 and that multiply to 72. So negative 9, negative 8, right? So negative 9, negative 8. And then I'll bring down the equal 0. Okay, make sure you bring down the equal 0. You have to keep it in equation the entire way through. Now, you could do one of 2 things. You could factor this further, right? Everyone sees that's dots. You could factor that to x plus 3 times x minus 3. Or if you don't want to, since you're solving an equation, right, you don't have to factor fully. You can just jump right into the t-chart. So that's your call. I'll do it both ways just so you could see. So for those of you guys that like to just jump right into the t-chart, what we would do is we would set each factor equal to 0. So I'm going to write 2x equals 0. I'll have x squared minus 9 equals 0. And we'll have x squared minus 8 equals 0. And you just solve these one by one. Okay, so starting over here on the left, 2x equals 0. Well, to get the x by itself, we're just going to divide both sides of the equation by 2. So these 2's cancel, and I get x equals, and 0 divided by 2 is 0, so there's one of our solutions. Okay, in the middle, we can add 9 to both sides of the equation. So it leaves us with x squared equals 9, and to get rid of a square, we take the square root. So a square and a square root cancel each other out, and keep in mind, this x squared tells us we could have up to 2 answers, right? So that's why we always put the plus and minus when solving, and the square root of 9 is 3. So here we get positive 3 and negative 3. And it makes sense, right? If I take positive 3 and substitute it back in for the x, isn't x squared, isn't positive 3 squared equal to 9? And then if I take the negative 3 and plug it in, isn't negative 3 squared equal to 9? So here we get 2 solutions. So far we have 1, 2, 3. All right, now let's solve this one. And we should probably come up with our other 2 solutions. So I'm going to add 8. I'm going to solve this the same way I kind of solved this middle column, okay? I'm going to add 8 to both sides, so I get x squared equals positive 8. And then to get rid of a square, we take the square root. So the square and the square root cancel each other out, leaving us with x. Oh, they're doing an announcement. Let me hit pause for a minute. Okay, so again, because this is a square, it tells us we could have up to 2 answers, so I'm going to put plus and minus. And then this time, 8's not a perfect square, so we have to simplify that radical. So I'm going to break this up into 2 separate radicals. And the biggest perfect square that divides evenly into 8 is 4. And since 4 times 2 gives us 8, I'm going to put a 4 in the first radical and a 2 in the other. All right, so now let's bring this down. X equals plus and minus. Now the square root of 4 is 2. And I'm just going to bring down my radical 2. Okay, so these are my final 2 answers. Plus positive 2 radical 2, and negative 2 radical 2. So altogether, we did wind up with 5 answers. Oh, I did say I was going to show you. Okay, if you wanted to factor this further, I'm just going to verbally talk about it. This x squared minus 9 would have factored to x plus 3 times x minus 3. And if you would have set those factors equal to 0, right, you would still wind up with the positive 3 and the negative 3.